In this video, we're going to be using distance time graphs to calculate speeds. Let's have a look at this example. Anna is cycling on mountain roads. She maintains a steady speed as she cycles some way from her starting point before taking a rest and then returning back to her starting point. Starting with question A, at what speed does Anna cycle before her rest? Well, first of all, let's see this graph. Where is she resting? Well, she's clearly resting after she has travelled 30 kilometres from her starting point. How do I know that? Well, once she reaches 30 kilometres away from where she started, she doesn't move for a while. She stays 30 kilometres away. So that means she's having a rest. She's staying still. And we can see that that actually happens between 4 and 5 hours after she starts. So how does that help us find the speed that Anna cycles before her rest? Well, we know that she has travelled a total of 30 kilometres until this point, and she does that in 4 hours. So her speed is simply going to be the distance travelled, that's 30 kilometres, divided by the time taken, that's 4 hours. And that gives us 7.5 kilometers per hour. Now, the main point of this video is to get you to realize that what we have just done is effectively find the gradient of this line. Let's think about that. How do we find the gradient again? Well, we want the change in the vertical direction divided by the change in the horizontal direction. If we look at just this section here, you'll see that we have gone a total of 30 kilometers, and that has taken a total of 4 hours. So the gradient would be 30 divided by 4, which is exactly what we've worked out. Just remember, however, that we could have found the gradient of this line by picking any 2 points on this line and finding the change in the vertical direction divided by the change in the horizontal direction. Change in y over change in x, if you remember back to that. For example, let's say I pick these 2 points, that one there and that one there. I could find the gradient as follows. This distance here is, well, the difference between 7.5 and 22.5. And that turns out to be 15. And this time taken is simply the difference between 1 and 3. So that's 2 hours. And you'll see if we work out 15 divided by 2, we still get 7.5. The key point is it doesn't matter how you find the gradient as long as you get the correct answer. Let's move on. How long does she rest for? Well, we already said that she was resting for this period here, between 4 and 5 hours after she started. So that's a total of 1 hour of rest. Let's just think about this as well in terms of gradient. What is the gradient of the line at this point? Well, it's 0. For every 1 step we go across here, we go 0 steps up or down. So the gradient is 0. And that indicates a speed of 0. And that makes sense. She's at rest. She's not moving. Finally, we've got question C. At what speed does Anna cycle after her rest? So for this phase of her journey. Well, we can see that she travels a total of 30 kilometers from there to get back to where she started. And that takes 3 hours. So 30 kilometers in 3 hours, we can see that we're going to get an answer of 10 kilometers per hour. But let's just think of this in terms of gradient, because this is an important skill and there's an important point to note. What is the gradient of this part of the graph? Well, remember, we would work that out by doing the change in this direction divided by the change in this direction. And we can see that this is 3 hours. From 5 to 8 is 3 hours there. And the change is this much. And that is negative 30. this part of the graph has a negative gradient because it is sloping down. So it would seem that what we actually get is negative 30 divided by 3, which should give us negative 10 kilometers an hour. Now, what we've actually worked out there is something called the velocity. The velocity of an object is simply its speed in a particular direction. So when you see a negative sign in a velocity, what that means is that it is traveling in the opposite direction to what it would be if it had a positive sign, like up here. However, the question hasn't asked us for the velocity, it's just asked us for the speed. So we don't really care which direction Anna is traveling in, so we can just write the speed as 10 kilometers per hour. We can simply ignore any positive or negative signs in our velocities. Before we finish, let's go back to part A. What did we actually work out here? Is this a velocity or a speed? Well, actually it's both. If we think of the gradient, what we actually do when we find the gradient is find the velocity. And in this case, we have a velocity of positive 7.5 kilometers an hour. Now, a speed is going to be what we get when we just ignore the sign of the velocity. We don't care whether a velocity is positive or negative if we're just interested in the speed. So a velocity of 7.5 kilometers per hour means a speed of 7.5 kilometers an hour. Compare that with down here, a velocity of negative 10 kilometers an hour means a speed of 10 kilometers an hour. We don't care about the negative sign if all we're interested in is the speed. We don't care about direction.